Next one, proportional voltage formula in series circuit. So here, what is mean by proportional voltage formula? That is a voltage division rule. We are also call it as a voltage division rule. Voltage division rule. So look at here. This is a series circuit. In the series circuit characteristics, current is same throughout the circuit, but voltage is drop across each circuit is different. That means in case this particular case, I will derive the formula how to find out the voltage drop across each resistor. So with the help of this circuit, I will do that. So here resistance R1, resistance R2, resistance R3. I will consider the voltage drop across the resistance R1 is V1, voltage drop across the resistance R2 is V2, voltage drop across the resistance R3 is V3. So whenever I consider the voltage drop, these two circuits are same. This is a complete circuit, it is represented. This is a circuit here connected, positive potential is connected to the supply and the negative is connected to the ground. This is also V1, V2 and V3. So these two are series circuits only. Okay. Now, what about the total equivalent resistance? R total resistance RT otherwise is equal to R1 plus R2 plus R3. Okay, fine. So what about the total voltage V? This is the, for example, total voltage V is equal to current is same. Total current I, current is flowing in the same current I. So here total voltage is equal to V is equal to total current into, that means same current into total resistance. This what? So I is equal to R1 plus R2 plus R3. Okay, let's consider this is the equation number 1. So you are attempting the objective examination, it is not required derivation, but theoretically or subject wise, knowledge wise, you are thoroughly about the concept. Then in the examination it is not like by hearting, it is like heartfully you are learning the concept. Then definitely remember these formulas. That's why I make the derivation to your understanding purpose. At the end, you need to note down in your notebook while you are watching this video. Those are taking our course in mobile app. Just maintain the one notebook for you. So you need to write the each and every topic, each and every formula. You need to memorize those formulas. But I will explain to you how to get those formulas. Then only your interest towards the subject. Right, you are electrical engineering or electronic engineering students, you know all these formulas, but I will make you understand better way. So this is the equation number 1. Next, once this is the equation you got. For example, I want voltage drop across the R1. So that will be equivalent to V1 is equal to I in Ohm's law, I into R1. Right. What is I from this case? I is equal to V divided by R1 plus R2 plus R3. Instead of this is equation number 1, this is equation number 1, right? Those equation number 1 substitute here. That will be equivalent to V divided V into R1 is there, na? Right? R1 divided by R1 plus R2 plus R3. All of you got my point. What is the formula for voltage division rule? You got the idea. What is the formula for voltage division rule? V1 is equal to total voltage into resistance R1 divided by total resistance R1 plus R2. So how to remember this formula in the examination point of view? What are maybe the resistance is given. So this is the circuit we have. So total voltage into, okay, what is the total voltage? In this case 24 into, okay, you want to find out the voltage drop across the V1, right? This particular V1, that means same resistance you need to consider, R1, right? R1, what is R1? 2 kilo ohm, 2k divided by, what is here? R1 plus R2 plus R3, summation of all three resistors, 2 plus 4 6, 6 plus 6 12, k get cancelled, here 1 time, here 6 times, 1 time, 4 times. What is the voltage drop across the first resistor? 4 volt. Clear? Next, similarly, we are going to write another equations. V2 is equal to total voltage into, we can say that R2 by R1 plus R2 plus R3, right? So again we can write it here. V is equal to total voltage into, you want to find out the voltage drop across the R2, that means R2 is equal to 4K. So 4K divided by total resistance is 12K, 1 time, 3 times, 1 time, here 24, right? 8. So what is the voltage here? 8 volt. And then what about the V3? See here, V3, directly we can write V1, V is equal to R3 divided by R1 plus R2 plus R3. How to write those numerically? V is equal to total voltage into, what is the R3 resistance you need to know? 6K, right? So 6K divided by 12K, right? 1 time and 2 time, it is equal to 12. What is the voltage now? 12 volt. So you got 4 volt, 8 volt and 12 volt. We can verify our answers. V is equal to V1 plus V2 plus V3. You need to satisfy in case of series circuit, right? What is the V here given? 24. What is the V1? You got 4. V2 you got 8. V3 you got 12. It is equal to 24 or not? 24 volt. That means our characteristics of the series circuit is satisfied. So this is about the voltage, proportional voltage formula or voltage division rule formula. Throughout, in case of transistors, throughout our KVS TGT work experience preparation, you need to remember this formula in your fingertips. Okay, right. Next, I will take some 2 cases. One is a transistor case, how to apply. Other one is a small circuit. I will apply how to do that. Series voltage dividers. This is a series voltage divider. So here in this case of series voltage divider, you know the formula. Here 2 resistors are present. What is the total voltage? 100. So I want to find out the V1. V1 is equal to, I want voltage drop V1. V1 is equal to total voltage into the resistance R1. What is the resistance R1? 150 divided by total resistance. What is the total resistance? 200, right? 0 0 0 0 get cancelled. 150 by 2 is nothing but a 75 volt. What about the voltage drop in between? 75 volt. That means 100 minus 75 is equal to, what is the voltage across B? 25 volt. All of you got an idea. It is a 100 volt, same directly, there is no internal resistance connected. Connecting wide voltage drop is 0, already you know. Though that means it is a terminal A voltage is 100, same as. After that R1 drops the voltage of 75 volt. The drop is subtracted from 100, you got 25. Now coming to V2. V2 is equal to, again, total voltage into resistance R2. 50 divided by total resistance is 200. So here 1 time, here 4 times, here 1 time, here 25 times. What is the voltage now? 25 volt. So here 25 volt. Subtract this 25 volt from here. What is the voltage drop now? 0. The terminal C voltage drop is 0. That means ground potential is same as C potential. This is the way you need to understand series voltage divider. Okay. Again, you need to satisfy our rule or not. Here 25 plus 75. What is our supplied voltage? 100. Satisfied. Next, we are moving to the another example. So you want to make a transistor is on position. The base voltage you need to require 3 volt. With the help of the voltage divider rule, we can calculate that whether it is a 3 volt satisfied or not. What is the supplied voltage here? 9 volt. That means voltage across this particular point is 9 volt. So this is a series combination, right? This is a series combination. Whenever this is a series combination, 6K and 3K connected in voltage division property. So I want voltage across this particular 3 kilo ohm resistor, then only you can calculate the base voltage, base to emitter voltage. So VBE is equal to, how to calculate? See here, VBE is equal to total voltage into resistance 3K, 3K divided by total resistance 9K. K get cancelled, 9 get cancelled. So that will be 3 volt. What is the voltage now? 3 volt. you require 3 volt, you can based on that this resistance values, maybe this is a variable resistor, we can vary the resistance up to this particular resistor, maybe turn on or saturation or cutoff region. We have 3 regions we have. We'll discuss later in the transistor case for your understanding purpose how to apply this particular division, voltage division rule in your transistors. Okay, this is about the explanation about the series voltage dividers. Okay, so next one is opens in series circuit. So in case of series circuit, if any resistor is open circuited or interconnecting wires are open, what will happen here? It is also very important topic. You need to understand the concept clearly. So this is a circuit we have, normal circuit. In this particular normal circuit, here positive and negative. What about the current flowing? The same current flowing here, I. The same current is flowing R2. This is a normal case. What happened if these two terminals are open? Here, these two terminals are open circuited. The battery, the current trying to flow this particular manner. What about it is open circuited? So whenever it is open circuited, current is equal to 0. The resistance across this open circuited R is equal to infinity. Resistance is infinity. What about the current will be 0? That means the current flowing through this particular element is 0. You know, from the IR drop concept, what is the voltage drop here? V1. I into R. I is 0 in case of open circuited R. What is the IR drop? 0. Coming to here, what is IR drop? IR drop is equal to I, current is 0 and R is equal to 0. All of you got my point. What is the drop across R1? 0. What is the drop across R2? 0. So that means what about the 12 volt same appear across this open circuited? Because the drop here 0, what amount of voltage you are connected, the same voltage appears across the open circuit terminals. So here resistance is infinity in the open circuited. Total entire open circuit voltage is a 12 volt. All of you clear? Just look at the this particular points one by one. In a normal series circuit, like one of the figure here, see, current flows and voltage drop across the different resistors are proportional to their resistances. Okay, here voltage drop E1, here voltage drop V2. According to their resistance values, the voltage drop will be appear. So if the circuit becomes open anywhere, I open circuited these two terminals, open anywhere shown in the figure B, following two effects would be proposed. Two effects we will consider. What are the effects here? First, open circuit. First effect is whenever open circuit will offer infinity resistance. Already mentioned. What is the resistance of open circuited? Infinity. So here circuit current will be 0. Yes, circuit current will be 0. Already mentioned. Consequently, there is no voltage drop across the R1 R2. Just now I mentioned voltage drop across the R1 is equal to 0. Voltage drop across the R2 is equal to 0. So hence, what is the second effect? See here, in the second case, all of the applied voltage would be left across the open circuit. Just now I mentioned, total entire 12 volt, there is no voltage drop, right? This total entire voltage drop appear across this open circuit. The reason for this, this is that R1 and R2 becomes negligible as compared to infinity resistance. What about the resistance we have? Maybe 1 ohm or 2 ohm, whatever may be the resistance. Compared to infinity, resistance in case of open circuited, remaining R1 and R2 resistance are negligible values. So which as practically the whole applied voltage drop across it, that means 12 volts across it, as per the proportional voltage formula, that means voltage division rule concept. So total entire voltage appears across the open circuit, that is infinity resistance. Okay, this is about the opens in series circuit. All of you clear about the opens in series circuit? Right. Then we are moving to the next one. Shorts in series circuits. Shorts in series circuit. So in this case, you know, 3 cases. I will explain with help of the 3 cases. See here. A short circuit has practically 0 resistance. Very important. Open circuit, infinity. Resistance is infinity. Just now we discussed. In case of short circuit, resistance is equal to 0. Every student have to remember this particular point clearly in your mind. Open circuited, resistance is equal to infinity. short circuited resistance is equal to 0 in case of ideal case I am explaining. Hence it causes the problem excessive current, which is in turn causes the power increases many times and the circuit components may burn out. I will prove that with the help of these numericals. So look at here. This is a normal circuit, right? What about the current here? Current I is equal to V by R. V is at 12. What is the R? 1, 2, 3. All are series or not? Series. That means 5, 6. It is equal to 2 amperes. All of you clear about the current? 2 amperes. Coming to here. What about the current here? I is equal to again V by R. In case of it is a short circuited, just now I mentioned what about the short circuit resistance is equal to 0. That means 3 ohm resistance is neglected. Resistance is equal to 0. So what about the total resistance now? 1 plus 2 plus 0. That will be 3. 4 amperes. Next is third case. Current here short circuited, right? That means what about the resistance? 0. This 2 ohm and 3 ohm are negligible. Total resistance 1 plus 0, 1. That is 12 by 1 is equal to 12 amperes. So what about the current now? Whenever you are short circuited, each and every resistance step by step, what about the current? Increases. This is the first effect. Coming to here. Whenever current increases, what about the power C here? P is equal to I square R. I square R is nothing but heat. The heat developed by the resistance circuit. So P is equal to I square R. What is I 2 whole square into what about the resistance? 1 ohm. Sorry, equivalent resistance is R is a equivalent resistance is 12. 1 plus 2, 3 plus 3, 6. I am sorry, total equivalent resistance is equal to 1 plus 2 plus 3 is equal to 6 ohm. Don't get confused. So I make it here 6. 4 square is a 12. No, 2 square is a 4. 4 6 is a 24. What is 24 watts? Coming to here, second case. So P is equal to again I square R. What is the I now? 4 square into R is a 6. 16 into 6. Okay. 4 square into R. What is the R in the second case? We can see here. R is equal to not 6. R is equal to 1 plus 2 plus 0. That is equal to 3. Okay. In this case. So that 3 place it here. That is equal to 48 watts. What is the power? Multiply double 2 times. Next coming to here. P is equal to I square R. What is I now? 12 whole square. What is R? C here. R is equal to 1 plus 0 plus 0. That will be 1 ohm. This is the third case R value into 1. That will be equivalent to 144. Okay, that means 144 watts. That means here it is a, for example, our circuit is designed for 24 watts. If you are short circuit any of these parameters, so what will happen? 24 watts. 6 times is increases. Whenever it is a 6 times increases, circuit may be burned. That's what point here. Because of excessive current, that is 6 times of normal current value, and other circuit components can become a hot, even ignite the and burn. Maybe it's going to be burned. So hence there should be fuse, which should be open if there is too much of current in the circuit. This is a 2 times repeated. The fuse will be there now. For example, if your fuse will be connected, the fuse going to be open circuited to protect our circuit. So this is what shorts in series and series circuits. So from this topic we completed complete concept related to the series circuits. In the next video we are going to discuss about the parallel circuit, complete topics mentioned in your syllabus. I hope that you are enjoyed the class. If you are interested, if you want to crack the exam, definitely our mobile app is a good guide for you to way to prepare yourself. So I hope that if you are interested, you can go and subscribe our course. Example 2.5. Find the values of different voltages that can be obtained from 12 volts battery with the help of the voltage divider circuit. So with this example, I will explain all the cases to find out the voltages. In the examination, you can they provide any equation, any circuit, you can find out the answers. You can play with the circuit. So see here. First I am going to find out the voltage across each resistor. I will tell you. So the voltage across the first resistor, that means V1 for example, V1 is equal to total voltage into, okay, total voltage into the resistance, 4 ohm resistance you have find out in the voltage, right? 4 divided by total resistance is 8. Voltage division rule. So that will be equivalent to 1 time 2 times, that is a 6 volt. So the voltage across VA is equal to, the voltage across the 1 ohm resistance is equal to 6 volt. What about now terminal voltage? VA is equal to 6 volt. VAB is equal to 6 volt. You got VAB is also 6 volt. No problem. Next, coming to the second, V2. V2 is equal to, V2 means that only voltage across the resistance R2. So only voltage across the resistance R2, 12 into the resistance, find out in the voltage across 3 ohm resistance. That resistance in the numerator, 3 divided by total resistance. Here 3 times 2 times 4.5 volt. So in this case, for example, VT is equal to 4.5 volt. So voltage between B and C, we can say that 4.5 volt. Okay. Next, second, V3. V3 is nothing but a total voltage into voltage division rule. The resistance is 1 ohm. You want to find out total resistance is 8. That will be equivalent to 3 times 2 times, that will be equivalent to 1.5 volt. So that will be equivalent to VCD. VCD is equal to 1.5 volt. So V3 is equal to 1.5 volt. Everyone is clear about up to the explanation about V1, V2, VAB, VBC, VCD. I am going to give some clarification related to the different voltages. You will get this few more clarity. I'm going to asking it to you. VAC. You want VAC for example. VAC is equal to here 6 plus 4.5. 6 plus 4.5, that is equal to 10.5. You can say that VAC is equal to 10.5. If you want VBD for example, VBD, what is the B value? 1.5. VB plus 4.5 plus 1.5, 6 volt. For example, you want VAD total. VAD is nothing but the total voltage applied here, 6 plus 4.5 plus 1.5, that is equal to, you can say directly 12 volt. So this is a way you need to understand the circuit clearly, then you can answer any question in the examination. Okay. Next example 2.6. So it is a very interesting problem. See here. Find from the figure, find values of R1 and R2 if the voltages applied across the load resistance is 1 kilo ohm is to be 20 volt. The voltage is given is 20 volt. The maximum current which the battery can supply 60 milliamperes. This is what they are provided, right? So they are asking, think about that. This is a 20 volt. That means indirectly these two are connected in parallel, right? What about the voltage now here? 20 volt. Fine. If you want to find out the resistance R2, definitely you want current, right? I2 current you want. So how to find out the I2 current? This current, I1 is equal to 60 milliamperes. So this current, you don't know this current, you need to find out that. See here, voltage, resistance. Voltage and resistance, you can find out IL current. IL is equal to, I is equal to V by R. V is 20 V by R. R is a 1K, 1 into 10 power 3. That will be equivalent to 20 milliamperes. You got. Okay, once this is the 20 milliamperes, once this is the 20 milliamperes, it is a 60 milliamperes. What about this current now? 40 milliamperes. That means you got I2 is equal to 60 milliamperes minus 20 milliamperes. That will be equivalent to 40 milliamperes. So once you got that is a 40 milliamperes, so directly you can find out R2 is equal to, current, resistance, voltage. R is equal to V by I. V divided by I is equal to 40 milliamperes. That will be equivalent to 1 time, 2 time, 1 by 2, 0.5 kilo ohms. What about resistance now? 0.5 kilo ohms, that will be equivalent to 500 ohms. Okay, you know the concept, you can make circuit anything, but the proper way of the application, the KCL or KVL or nodal analysis or superposition theorem or mesh analysis, what it may be, clear cut idea about the concept, definitely can find out the solution easily. Next, you want to find out the R2. How to find out the R1? How to find out the R1? This is 60 amperes, 60 milliamperes. I1, What about the voltage here? The voltage in between these two, this is 100 volt. This is the 20 volt. What about voltage now? 80 volt. So V2 is equal to 80 volt. So then R2 is equal to, voltage into, current 60 milliamp. So R is equal to V by I. What is the V? 80. What is the current I? 60 milli. 0 0 get cancelled. So 1.33 kilo ohms. That will be equivalent to 1300 3.3 ohms. Okay, we got R1 value also. This is a V1, this is R1. Finally got R1 value also. This is about the solution. R1 value is a 1333.3 and R2 is equal to 500 ohms.